All right, let's start our today's session. So basically, the first question we need to discuss is question number 8 from the worksheet only. So it says that the sound causes an explosion. By explosion, ocean's surface travels vertically down to the bottom of the ocean, is reflected and return to the surface in 11.6 seconds. So how can we actually think about it? So suppose this is the surface of the ocean, or you can say the bed of ocean, and there is something which causes explosion at this particular point. So because of that explosion, sound travels to the bottom of the surface and then went to the bottom and then goes back to the it. So here are two things: time of ascent and time of descent. What does it mean? Time of ascent is something which is used to represent the time taken by the particle to reach up in the upward direction, and time of descent is something time taken by the particle to reach to the bottom side of the motion. So it should be time of ascent and it should be time of descent. So the sum of these two times is given as 11.6 seconds, like that. So we have to calculate the depth of the ocean if the sound travels at 1450 meters per second in water. So we have given speed of sound also. So speed of sound is given as 1450 meters per second. We have to calculate the depth. So how can we calculate the depth? By using the formula of speed. So what we know is that speed is nothing but distance upon time. We have to calculate this distance. The distance is going to be speed into time. So as you can see that we have to calculate the depth. So it is going to be speed into time. Speed is 1450 and it is the total time of ascent plus time of descent. So what do we actually supposed to substitute here is half of this value, because in order to calculate the depth, the distance covered is going to be depth only. Speed is already given, but what is the time taken in order to move in one particular direction only? It should be half of it. So I would write 11.6 by 2. Once you solve this, you will get the value of depth. So it is approximately 725 times 11.6. What it is, tell me.
Um, 8,410.
Meters. Also, you can convert the unit and also write the depth in kilometers. So it is going to be 8.41 kilometers. So this is how we are supposed to solve this. Very simple, very basic question. But although you need to understand that how actually sound is traveling through the given information. Let's go to the next question. The question 9 says light from sun reaches earth in 8.3 minutes. So this is given as time taken by light to reach from sun to earth, 8.3 minutes. Again, in order to solve any problem here in physics, we need to convert things in SI units. So SI unit of time is seconds. So 8.3 must be multiplied by 60. And when we multiply it, we'll get 498 seconds. So this is the time taken by sunlight to reach surface of earth from sun. All right, we got this. How far is earth from the sun in kilometers? This is what we have to answer. That is, we have to find out distance between sun and earth. This is what we have to find. But in order to do so, we need to have the velocity of the sunlight, that how fast sunlight or light travels. So in order to write this, we know that speed of light is nothing but, do you know what is speed of light?
No.
Okay, this is something you have to remember from now onwards. It is 3 into 10 to the power 8 meters per second.
Okay.
This is something we need to learn, or in most of the questions, it is mentioned, but in those questions in which it is not mentioned, it is supposed to assume that student already know this, because this is something we have to learn, factual data you can say. So again, We know speed is nothing but distance upon time. We have to find the distance. So we'll simply write distance is going to be speed times speed into times. So speed into time. So speed is 3 into 10 to the power 3. Oh, sorry, 3 into 10 to the power 8 meters per second. So we'll simply multiply the same with the time, which is supposed to be 498 seconds. So when we multiply it, we'll get 4, 2, 7, 9, 2, 12, 14 into 10 to the power 8 meters per second. We can also write it as it is going to be 1.494 into 10 to the power 11 meters. So this is something we found in meters, or in any other unit we want to find it out, we just convert this value. The distance is going to be 1.494 into 10 to the power 11 meters. This is to be precise.
Wait, why is it to the power of 11? Oh, because you moved the decimal point back.
What?
Why is it 10 to the power of 11, not 10 to the power of 8?
I have simply shifted the point decimal. So
Yeah,
if it is 494 meters, so can I write it as 1.494 kilometer?
yeah.
So this is something which can also be written as 1.5 kilometers. So in order to
Okay,
convert it into kilometers, we can simply say it is approximately 1.5 into 10 to the power 8 kilometers.
okay.
So based upon the options, whichever option is there, you can choose your correct answer.
All right.
Yeah. Let's move to the next question. Question number 12. Question number 12 says, at 12:30 p.m., a Mack truck traveling east at a constant speed 54 miles per hour. So in order to do these questions, we have to write things according to the axis, or you can say according to the directions, because here we have to figure it out the position of the truck at 5 p.m. So at 12:30, we have to remember the time. Let's say truck starts from this position and it is traveling towards east. So it must be going towards this direction, east, with constant speed 55 miles per hour. And it is traveling 55 miles per hour is 134 miles west of Dublin. So what does it mean? It is traveling east one at 55 miles per hour, and it travels 134 miles west of Dublin. So where is it supposed to be at 5 p.m.? So you have to remember the vectors here, and we have to know that how vectors are being used. So what do you feel like? How can we do this?
Um, so first it goes east,
Yeah,
speed
first it goes towards east,
is 134. But okay.
and it is 134 miles west of Dublin. So we have
So
given that, yeah, go ahead.
if it's going east, then why would it be 134 miles west?
It's the thing is, it
Yeah.
is 134 miles west of Dublin. Matlab, you can assume that it was initially traveling in west and now it is going towards east. So how much he has traveled towards west? So it is something like that. So initially it was
Um,
there, it was traveling towards west and it covered somewhat 134 miles. Then suddenly at 12:30, we start moving towards east with 55 miles per hour. And the question says, what is the position of the truck at 5:30? So when it is traveling, so it must have traveled this much distance. 5:30 is supposed to be the time. So how can we calculate it? So simply we need to understand, or we need to calculate that how much distance will it travel in the given time period. So if you look at the time, not 5:30, it's 5. So if you look at the time, it says For how much time is the truck traveling? First of all, tell me this. For how
Um,
much time the truck is going to travel?
30 minutes. Uh, 4 hours, 30 minutes.
Yeah. So total time for traveling is going to be 4 hours, 30 minutes, like that. Now, the speed is given as 55 miles per hour. So how much
Yeah.
distance will it travel in 4 hours, 30 minutes?
55 times 4.5.
55 times 4, 1 by 2, like that. So it can be
Yeah.
written as 55 times 9 by 2. So it can be written as, it is going to be 490 by 2. Or you can say 495, not 490, 495 by 2. It is coming out to be how much? 247.5 miles. Now, understand the situation once again. So the truck initially traveled a distance of 134 miles towards west of Dublin. So suppose this is the Dublin, this is the place where we're talking about, it is Dublin. Then the same particle started traveling at 12:30 towards west, towards east. So how much distance it has covered? 247.5 miles. The question says, what is the position, or where is it at 5 p.m.? So how we are going to find it out? Because it is actually asking for the position. So position can be given by calculating the displacement. So displacement is going to be 247.5 minus 134, which is
Yeah.
approximately 113.5 miles. Now, what is the direction of this? So we can say it is 113.5 miles east of Dublin,
Yeah.
because now from Dublin it is moving towards east, so east of Dublin. So this is how we are actually going to represent the position by considering the direction as well. This is the most important thing about it, east of Dublin. So this was all about the first part, I would say. The second part says, if instead the Mack truck was east of Dublin at 12:30 p.m., but still traveling east at a constant speed 55 miles per hour, where the car is at 5 p.m. So the question says, now the Mack truck was east of Dublin at 12:30. So now this became very easy now. So suppose this is Dublin and particle was east of it initially, and this distance was 134 miles. Was the time 12:30 p.m. and it is continued traveling towards east at constant speed 55 miles per hour. So it is traveling towards east only. So the question says, at 5 p.m., what is its final position? So we know that during the process, it has covered 247.5 miles. So from Dublin to this particular time, how much total distance it is going to cover? Can I add
Mm,
these two numbers? 134
yeah.
plus 247.5.
Yeah.
So it is going to be 0.5182, 3. So 381.5 miles. So we can say that the final position at 5 p.m. for the second case is going to be 381.5 east of Dublin. We have to mention the direction always whenever we are writing any particular question here.
Okay.
So does it make sense?
That makes sense.
All right. Let's move to the next question then. So question says, Boston Red Sox pitcher Roger Silliman can routinely throw a fastball at a horizontal speed of 160 kilometers per hour as verified by the radar. How many seconds does it take the ball to reach the home plate 18.4 meters away? This is very simple.
Mm.
How we are supposed to solve it? Tell me.
So we have distance. I mean, we have Yeah, we have distance, which is 18.4 meters. We
Yes.
have speed, which is 160 kilometers per hour, and we need
So
time.
this we have to find out time. Now,
Yeah,
what's important here is to convert the speed. Without converting speed, we actually cannot find out a time. Why? Because speed is given is kilometers per hour and we have to convert it into meters per second. How can we do so? 160 into. Now, what is how many meters are there in 1 kilometer?
um, is it 100?
1000.
Yeah,
And how many seconds are there in 1 hour?
um, and 3,600.
Correct. So when we do this, like when we multiply 160 by 1000 upon 3600, so we'll get velocity in meters per second. We have to simplify this equation. That's it. See how we're going to do this. 5 by 18. When we solve this, it will be around 80 by 9. So it is going to be 400 by 9 meters per second. So we got the speed in meters per second. We had the distance in meters per second. Now we can find out the time. So as we know, speed is nothing but distance upon time. So time is going to be distance upon speed.
Yeah,
So it will give us distance is 18.4, speed is 400 by 9. So just solve it and tell me the value of time.
okay. 0.414 seconds.
All right. Yeah, that's correct. Answer key says the same. All right, let's move to the next question. The
Okay.
question number 21. It says that you and a friend each drive 100 kilometers. Your friend drives at 89 kilometers per hour and you drive at 95 kilometers per hour. How many minutes will you have to wait for your friend at the end of the trip? That, that how much time we actually need to wait if he's traveling a little at a little lesser speed, I can say. So let us write the two cases here. First, for you, and second, our friend. So the distance covered for both of them is 100 kilometers, right?
Yeah.
Speed is given as 89 kilometers per hour, and here speed is given as 95 kilometers per hour. Question says how many minutes? So you have to find time in minutes.
Wait, it's the other way around. We drive 95 kilometers 89.
What?
We drive 95 kilometers. Friend drives 89 kilometers. You have to switch up the speeds.
Okay. No issues. We have to find the difference. It won't change.
Oh, yeah.
So time is going to be distance upon speed. So here distance is 100 kilometers, speed is 89 kilometers per hour. Here again time is going to be 100 upon 95. So when you solve this 100 by 89, tell me what is going to be. And similarly 100 upon 95 as well.
1.12 per 100 by 89. And then,
That is going to be 1.12 hours. Remember this
yeah, hours.
unit.
And
It is
then,
going to be 1.12 hours.
and
And
that's
next
0.05 hours.
0.05 hours. No, it is wrong.
That's 100 by
100
9.
by 95. It should be 1 point something.
Yeah, it is 1.0526.
Yeah. So 1.05. Let me keep it till here only. So that too in hours. Now we have to convert this time in minutes. So in order to convert hours into minutes, what we actually do?
Mm,
Multiply both the numbers by
six.
60. Do it and tell me the value.
First one is 67.2 minutes.
It is going to be 67.2 minutes.
Yeah,
All right. And what
second one
about
is 3 minutes.
how much for this?
63.
Okay. So I guess you got your answer.
Yeah,
How much time do we have to wait?
about 4.2.
Exactly. So this is how we are supposed to solve these kind of problems. Just compare them, apply the concept what we have learned so far, and you get the answer. All right, let's move to the next question. Question number 26. So question says, what two controls on a car enable it to change speed? What additional control allow you to change speed? So that is a very simple thing. And this is something which is specifically asking, now what does it mean changing speed? Changing speed means, let us try to understand it. So suppose I'm taking an example of circular motion to make you understand this particular part.
Yeah.
Suppose a car is moving around a circle. It can be like that. So there was a car, this point, and when it reaches this point, you can see at both the points, initially its velocity is in this direction, at this point is going to be in this direction. So at every point, the velocity of the car is going to be tangential to that circular path. It is not something which is related to or which is limited to this part only. This is very basic thing and we need to understand it accordingly. So the velocity has two things as we already mentioned. Velocity of any particle moving possess two things. The first it is magnitude of velocity. The second it is direction. Why? Because velocity is a vector quantity. So it has magnitude as well as direction. This is already we have seen in understanding vectors. So question says if you want to change, if you want to control car in order to change its speed, how can we do so? So
I guess.
if I need to change the speed, what out of these two things I can change so that I can actually get change in speed?
Hmm. Well, if you change direction, then that can change the speed.
Just think wisely.
I mean, like logic. I mean, yeah, but yeah, magnitude would make more sense. Velocity,
क्या? Sorry, what?
magnitude.
Yeah, magnitude. Remember the part. If
No,
I'm
but like
talking
I was
about
thinking, if
velocity,
you like change direction, like you
that
would have
will
to.
change again, understand. If we are able to change the magnitude of the velocity, let me write it this way. If we change the magnitude of the velocity, we will be able to change speed. Understand this thing. If we are changing the magnitude of the velocity, we'll be able to change the speed. Second part says what additional control allows you to change velocity. The additional part says if we change the direction, will be able to change velocity. Now, these are the two different things. When we are changing magnitude, we are changing speed only. But when we are changing direction, we are changing magnitude, we are changing velocity. That is the most important thing. Remember this for every vector quantity. This is not limited to this velocity and speed only. It is related to the every vector quantity. If you are able to change the speed, it can only be done by changing magnitude. Like for example, suppose initially it was 10 meters per second, and then after some time it becomes 12 meters per second. So how we are able to change the velocity? How we are able to change the speed? By changing the magnitude. But if we actually talk about the direction, so we can say initially the velocity of the particle was supposed to be towards east, and after some time it becomes towards north, and later on it becomes towards west. So what we are doing here? We are changing the direction. If we are changing the direction, we are allowing change in velocity.
Okay.
Yeah, so this is the thing that we need to remember. All right, let's move ahead. So we got the answer for both the questions, additional control as well as normal enable control to change speed. Next question. Can the speed of an object be negative? If so, give an example. If not, explain why. So I guess you should at least try this once that what it is going to be. So here you can easily see that speed is a total path length covered per unit time, whereas velocity is a net displacement per unit time. So there is no direction for speed. We cannot change the direction or we cannot talk about the direction of speed. But we can talk about the direction of velocity as direction of velocity is something which gives us direction of displacement. With basically whatever direction displacement possess, that direction will be the direction of velocity. So the question says, can the speed of the object be negative? If so, give an example. So how we are supposed to answer it? See. So we will simply say the speed cannot be negative. Cannot be negative. Why? Because it is a scalar quantity. Because it is a scalar quantity and negative sign in any physical quantity it represents only direction. It represents only direction. So speed is something which cannot be negative because it doesn't have any direction. Whereas velocity can be negative because it shows direction. Let me give you the example of both positive and negative velocity. So you'll be able to understand why speed cannot be negative. Suppose case one. Initially particle was at this point, it went to this point, then came back to this point. So here the displacement vector, if I want to draw, it should be draw from initial position to the final position.
Yeah.
The displacement vector should be drawn this way. This is first case. In second case, I would say particle A started traveling from point A, went to point B. Then from point B, he takes a U-turn and went to point C. Here in this case, the displacement vector is going to be drawn from A to B like that. So A was supposed to be the initial position in both the cases.
Mm-hmm.
So if I say in the first case, the position vector has been drawn towards positive x-axis.
Yeah.
So if it is positive x-axis, then it is negative x-axis. So can I say in the first case as direction of velocity is similar to direction of displacement. So in the first case, velocity is going to be positive. Similarly, in the second case, the direction of displacement is given by what? Tell me.
Mm, the way the direction, the ending, um, the S vector
We'll
is
simply
going.
say,
Oh,
negative I cap. Here we can mention it positive I cap. So velocity is going to be in the second case as negative. But speed cannot have these two things. It is always positive. It cannot be negative because it doesn't have any direction. We won't talk about any direction when we are talking about speed.
yeah,
So this is how we are supposed to solve these kind of problems. Are you getting each and everything?
yeah,
All right. Let's move to the next problem. Question number 30. You were saying that there were 10 questions, but I guess there are only 1, 2, 3, 4, 5, 6, 7, 8.
yeah, eight,
Only 8 questions were there. All right. So
yeah,
this is the 8th problem. Although the PDF has a lot of questions, you can practice the remaining one also. And if you found any problem in doing any problem, you can ask. And I would suggest you that you should do the problems, remaining problems. This will
yeah.
only help.
Okay.
All right. So let's talk about the next question. That is question number 30th. A weather balloon continuously radios its elevation back to the base station. They are as follows. So at time is equals to 0, the elevation was 1.2 kilometers. When time was 5 minutes, that elevation reaches to 1.6 kilometers. At time is equals to 10 minutes, the elevation reaches to 1.9 kilometers. At 15 minutes, it is 2 kilometers. So from 0 to 15, it is continuously going up. So if I represent the same using a graph, that would make it more sensible. So this is going to be my time axis. This is initial position supposed to be O. And
Wait,
you can say,
just to clarify for the last question, the reason why speed cannot be negative is because it's a scalar. Uh, I mean, it's a magnitude. So, but then other hand, velocity, it's direction, and that negative I cap just defines the direction going to negative axis. That's why it can be negative.
yeah. And
Okay.
you should tell it more specifically that speed cannot be negative because it is scalar quantity and doesn't have any direction.
Okay. Got it.
So if it doesn't have any direction, we cannot use negative or positive sign.
Got it.
All right. So the next problem
Yeah.
we says that this is the time instant we have given. So at 0, there was some position. So this is 0 minute. This is 5 minutes. This is going to be 10 minutes. This is going to be 15 minutes, 20 and 25. Now let's see the position, how position is changing. This is interesting. Initially, the position was 1.2 kilometers. Then it became 1.6. Then it became 1.9. Highest it goes till 2. And lowest it came to 1.1. So if we try to plot the graph of the same, this is going to be the position time graph to be precise, that we might not talked yet. But yeah, this will help to understand. So position time graph, if we have drawn, so we can see at 0, the distance is 120. So the graph will start from this point, 1.2.
Yeah.
It keeps on going till 15th minute. So let me just mark the points. Similarly, at 10 minutes, it was 1.9 kilometers of elevation. At 1.6 elevation, it was supposed to be taking 5 seconds. So it is going like that. So the graph easily shows that the position of the particle keeps on changing like that. And during that time, it is ascending, it is moving upward.
Right.
Similarly, this is going to be the point 1.8. And I'm drawing this point to represent the further position at 20 minutes. At 1.1, the time was again supposed to be 20 minutes. So later on, it has gone like that.
Okay.
So what we have drawn? We have drawn position time graph. Doing these kind of questions through this method is very easy, and sometimes it almost clarify whole questions when we just draw that graph or try to represent any situation graphically. It will help us a lot. So how
Mm,
we are supposed to do so? So in order to do so, let's talk about this graph only, or we can actually do it by general method. Let us do it by general method. So first question says, what is the average velocity from 0 to 25 minutes? Now they're talking about velocity.
so I need
So we can talk about velocity only. Let's answer the question number fifth first. E part. Why we cannot calculate the balloon's average speed? Why we are calculating the average velocity? Because speed is something which doesn't have any direction, but in this case, the particle is moving with respect to a certain point and coming back to the same point. That is ground. So when balloon is rising, how it is supposed to rise? It must be rising that it's going like that and coming back to the same position like that. So with respect to the ground, its distance is changing. Sometimes this, then this, then this, then might be this. Then again it reduce and come back to the initial position like that. So here what we understood is that we cannot find the distance because distance, sorry, we cannot find the speed because the particle is moving first up and then down. So this
yeah,
makes that it has displacement during the time interval. So during the time interval, whatever displacement the particle does, it is divided by that time, it will give us the velocity or average velocity, you can say. So how can we define average velocity? So average velocity is the physical quantity which explains the net displacement during that interval over total time. So what is net displacement here from 0 to 25 minutes?
um,
You can figure it out very easily now.
so 25 is total, and
During total time 0 to 25, what is the net displacement?
you
At
compare
0, it was at 1.2 kilometers away. At 25, the balloon is
1.1.
1.1. So what is the displacement? This is going to be the displacement.
Yeah, zero
It
point
is going
one.
to be 0.1. So average
Yeah,
velocity for the first part is coming out as 0.1 by total time. And what is the total time? 25 minutes.
yeah,
So we have to convert the time into seconds, and this distance, that is kilometer into meters. So it is going
that's
to be 25 minutes. So when we convert it, we'll get 100 meters by 25 times 60. What it is
yeah,
going to be?
that's like
150 into 5, 150 into 10.
1,000.
It is going to be 1 by 15 meters per second, or you can also solve it to the decimal point. So did you got it that how we're supposed to find the average velocity during that interval?
Yeah, I got
Just
it.
try to calculate the displacement and you'll be able to find out what is the average speed, average velocity. In the
Okay.
second case, average velocity is going to be again 5 to 10. So from 5 to 10, how much distance? Oh, sorry, what is the displacement between the 5 and 10th point?
So 5 is 1.6, 10 is 1.9, so that's 0.3.
And how much time it has
Uh,
taken?
5 minutes. Then you have to
Yeah, so 300 meters by 60 into 5, that is 300
yeah,
seconds. So it is going to be
1 by 100. Sorry,
1
yeah,
meters per second.
1 meter. Yeah.
In the third part, 20th to 25 minutes. What is average velocity? Tell me, what is the displacement?
Displacement is 22, 20. That's 1.8. And then that's 1.1. So that's 0.7.
And time,
5 minutes.
so it is going to be 700 by 300. That is going to be
2.5.
around
No, not 2.5.
2.33 meters per second.
Yeah.
The last part, option D, it says if the weather balloon velocity after 25 minutes is the same as that of from 20 to 25 minutes, when will the balloon hit the ground? The question says that after 25 minutes, after this time, it has the same velocity. Its velocity is supposed to be 2.33 meters per second.
Yeah.
It says in the question, after 25 minutes, it is the same as it is from 20 to 25 minutes. So, in during that time, the velocity is 2.33. So, after 25 minutes also, its velocity remains same. So, how much time will it take to hit the ground? So, time, we have to calculate time. Time is nothing but distance upon speed. How much distance the balloon has to cover in order to reach the ground after 25 minutes?
Um, 1.1.
Yeah, 1.1. And what is the speed with which it is traveling?
2.31 meters per second. Or 33.
Now we have to convert these kilometers into meters. Then only we can find out time. That is going to be 1100 meters by 2.33. So how much time will it take? Tell me. Divide it and tell me. 1100 divided by 2.33.
That's 472.1.
And how much this time is in minutes? Divide it by 60 also.
That's 7.86. I mean, so 7.87.
So that is going to be the time it will take to reach the ground, that balloon. So 7.87 minutes.